Hello, hello. And this notes page is going to be really a whole lot more notes and a lot less like examples, but you'll see a little bit of both. We're going to talk about direct and inverse variation. And we'll do a little fill-in-the-blank definitions here. We'll also, you're basically using proportion, okay, to solve these types of problems. When there is well, let's fill in the first part. The first blank is going to be, there are two types of variation, direct and indirect. And direct variation, that means as x increases. Again, sorry, it's hard to write. Y increases. And I'll just let you finish writing that. Or, same idea, if x is decreasing, then y is also decreasing. So a good example is the more hours that you work, the more money that you earn, assuming you're paid hourly. All right, then the opposite of that, inverse variation, as x increases, y decreases. So the more miles that you drive, the less gas is in your tank is a good example. So as you drive, the car burns gasoline and it decreases. The miles driven would increase. The gas in your tank would decrease. So that's an inverse variation. Key point, and this is going to be, there's a way to set up the ratio depending on how we're doing things. But in both cases, you'll have a constant of variation. And a lot of times in your math and sciences, we will use the letter K to represent a constant. You'll see this again. All right, let's look and see how that ratio might look with this example. So, study the table below, determine the type of variation. Well, in this particular example, I hope you noticed that as your hours of work increase, your total pay increases, so this is direct. And so if we were to consider this hours worked, X, and the total pay, Y, then you could find out a constant by setting up this direct variation problem as 30 over 5 equals 6. In other words, you are, in this example, let's just kind of make some room here, 11 over 60, I'm sorry, other way around, 66 over 11 is equal to 6. 84 over 14, that equals 6. So if you are getting the message here, you're earning $6 per hour. $6 per hour is your constant. So K, in this example, is equal to 6. A general equation for direct variation is the constant equals y over x. And another way to say this is, you'll learn this, maybe you've already seen it, your y term, if you wanted it in terms of y is equal to k times x. So these are really saying the same things, those two different variations of the general equation. Okay, so let's go ahead and look at some more examples, try to get that meshed into our brain. if y varies directly as x and y equals 6, then x equal 8. Okay, well our general formula is, again, k is equal to y over x. So it gives us something to start with. So it gives us something in which to figure the constant. So we would start with 6 over 8. Then it tells us to find something where one of the y or x terms is missing. So in this case, it says to find y. Y is always on top in this example, or with direct variation. And it gives us an x of 12. So we can set up a proportion problem where we would cross multiply to get an answer. So to find y, you would multiply 8 times y and 6 times 12, which would be 72. To get back to y, we need to divide everything by 8, and so for this one, our y value is 9. So given this information, it essentially told us how to find the ratio, the constant, by giving us the 6 over the 8. And then it asked us to find a missing piece, y. And sorry, Joshua, or not Joshua, no, Jeremiah. We probably are going on 15 minutes plus on this one. And so number 3 on the next page, it's telling us that a spring stretches, the amount of force required is F, varies directly with the amount the spring is stretched, S. So if we were to treat the F and the S like the Y and the X, we would look something like this, just to remind you, K is equal to Y over X, and you could also say F over S, because they're serving the same purpose. F is like Y, it depends on X. And so X is on the bottom, S is on the bottom. Alright, so let's try this out. 10 pounds is needed to stretch the spring 8 inches. So our first ratio would be 10 over 8, and that would be proportionate to what it's asking us to look for, how many pounds of force, that's the missing piece, is needed to stretch the spring 32 inches. Okay, again with the cross multiplying, clear some room, we get 8F is equal to 320 divided all by 8, and F would be 40 pounds. £40 needed to stretch the spring 32 inches. Okay, the amount, or the distance driven, D, varies directly with the time traveled. T, if you have driven 175 miles for 5 hours, how long would you drive for 210 miles? Okay, so our K is equal to Y over X equivalent. That's really nasty. Is your distance over time. The distance driven depends on the amount of time that you drive. So dependent is on top, independent X is on bottom. This first one we'll set up with, if you've driven 175 miles for 5 hours, how long would it take you to drive 210 miles? Cross multiplying gives us 175D. Oh, sorry, that didn't come out right. 175D equals 210 times 5 would make 1050. Divide it all by 175. And my D term is 6 hours. And you want to get used to telling me what the units are when you can. So we would write 6 hours.